Hello, this is Nick of Time. Welcome to this, our 13th talk in the series. And the first bullet is going to show what we've talked about, what we found out. Second bullet is where we are in the series, and the third bullet is where we'll be going. So, starting with the first bullet, special relativity doesn't describe clock rates as a function of velocity. And in special relativity, they use the construct of relative velocity. But GPS data shows clock rates are a function of velocity. In fact, a function of absolute velocity. Velocity with respect to a single preferred frame. Okay, we're in part 2 of the series, and we're looking at the empirical data. And today, we're looking at particle accelerators. In part 3 of this series, we'll look at a better strategy for physics to handle time than special relativity provides. Yes, here's a particle accelerator. This is CERN, and the picture is provided by CERN, and it's a massive device, and as you can see in the upper right-hand corner, overlooking the operation of this accelerator, making sure that everything is set up perfectly. A huge device, super expensive device, super complex device, has to be handled with great precision. Very impressive device. Okay, what does the particle accelerator data show? Well, accelerators were one of the early primary supporters of special relativity. But accelerator data was also consistent with preferred frame theory, such as Lorentz relativity. It supported both special relativity and Lorentz relativity because the data was only from A's view and not B's view. In other words, it was from the scientist's view, but not from the particle's point of view. So he couldn't tell if the data was symmetric, like special relativity's time dilation equation, or if it was asymmetric, like Lorentz relativity's clock retardation equation, which look the same except for one uses relative velocity and the other uses absolute velocity. A little bit more on the preferred theory interpretation. For a preferred frame view of clock rates as a function of absolute velocity, the preferred frame would need to be the ECI frame to explain the clock retardation data from particle accelerators. And for this data, accelerators such as CERN, the one we just saw, use the ECI frame as the base frame, just as GPS does to get the best results. So that's encouraging. Well, it's been a short talk and nothing profound, but we have to look at all of the pieces because they all come together like a jigsaw puzzle to provide the right answer, the right picture. Conclusion. The data from particle accelerators on clock rates as a function of velocity could be interpreted as supporting either special relativity or Lorentz relativity. So, thank you for joining us for this short talk, and hope that you'll be able to join us for the next talk as we look at more empirical data. Thank you.